Hello, I welcome everyone to this video session, and this video session is very important for those who want to learn robotics. Uh, Robotics is very important. Nowadays, every application of AI and control system that is backed by robotics. Without robotics, in near future, it's impossible to make accurate, precise control system, whether in industry and in our daily life. You will see that the robotics have, the cover all of our critical jobs. So in today's video session, in the previous video session, I have tell about the ROS robotic operating system, about its general overviews, about its packages, ROS code. But in today's video session, I'm generally more want to go in a deep that is how Python nodes are working and how we use the Python nodes inside the packages of the Catkin workspace and how Python nodes are important nowadays. Um, so before this, I will tell you in the general that we are working on the one of the rover. That rover is working based on the control of Python publishers, and that will send velocity command to the Arduino microcontroller. And basically, for these nodes, we are using ROS Raspberry Pi, which is a single board computer. The benefit of single board computer microprocessor is to use in that the autonomous vehicles. Is that it's compact in size. You can easily install that hardware. So we will not go in that side, but we will be limited to the Python nodes and the custom workspace. So this is the Ubuntu, and we have the set of the ROS robotic operating system on this. And I have created the packages. Uh, Generally, before when you are starting with the packages and nodes, you have to create the Catkin workspace. Uh, Inside of this Catkin workspace, you have the source folder install and develop view folder, but source folder is very important folder as in this folder you will have a different packages and so this is my source folder and inside of this source folder I have different packages what is one is the Arduino push RC card control and the RC card control the raw serial and RP leader raw serial. These packages we will be used in a future videos. So, but I will go in more simple way towards that stage. As that stage is more complex, as we have worked on autonomous vehicles, and we have used these packages for that critical stage. So I will go with simple first packages that is the car control. And so this is the Python packages. Sorry, the ROS packages, and you have select list. When you want to build the package, you will have to name the packages, and after naming, you will have to select get in select to introduce packages to the ROS environment, and there's a step-by-step processes. When you are new to ROS with robotic operating system, then this video is not surely for you. You have to go back and you have find a very good sessions on YouTube where the basic of the ROS, how ROS is installed, how the package is created, step by step, the command line terminals commands. You will use the Linux to make the packages of ROS, use the uh, terminal uh, but I will not go with that. I will limit myself to the Python nodes and packages which I already have made. So this very session is a little bit for advanced user of ROS. So I will show you. This is the source folder of Catkin Workspace. Inside, I have created some packages, and I will explain the nodes, the Python nodes. Uh, so this is my package, and you have, when you want to create the car control packages, any package, you will have some, package descriptions about how the package works and what is the name of the package. So the name is the car control, and the user is me and the mom. And also you have to do what the license and everything. Uh, who is the real owner of this package? So all of these things are, you will have uh, package such as the geometry messages you are using in Python node for the pivot message command velocity messages and the raw spy geometry messages and ROS is the Python libraries that are working with the ROS specifically, and you will have you know different type of functionality that are coordinated between Python and the ROS. So I have this Python node. I will tell about the functionality of these nodes. Whenever you want to make any Python node, and you will have to go, in terminal. Different people use different approach to make the Python node, but I will give you a very simple way to make the Python node before naming the nodes and how to create. Uh, you can generally directly use the Visual Studio. Uh, for using, you can use the terminal just one command, just to the code, and you will get the Visual Studio. So yeah, I'll reopen it. Visual Studio. This is as before I was coming to the Catkin workspace. Inside the Catkin workspace, you will come to the source folder as I have show you. In source folder, I was in the car control package. You will go to the car control, and then in the car control, you will have a different uh, Python node. So like I have created inside that source folder different nodes. One is the car control, navigation, move backward, move forward. And so these are the Python nodes that I have already created to send the command velocity to the Arduino microcontroller. And that Arduino microcontroller will have to act on that command. I will show both the nodes. And the next video sessions, I will show you the RC for how it's controlled by this node and how Arduino is controlling that node to make a simple RC robot. And we will also go for that video in the next video session. Before that, we have to clear the Python node, how the Python nodes act, how the Arduino sketch. This is the Python nodes that we have created. First, this is Python 3 environment. You have to, if you are using Robotics ROS, then you have to use the Python 3, which is not for Python 2 and other. It is specifically for Python 3 environment. You have to declare that environment Python 3. So first we have import the ROS-Py module in that Python node. Remember, this node acts as a publisher. Uh, we will go also further. I will explain first how this node is working. First, we have Python 3 environment. We have declared this. And after that, we have import the ROS file. The ROS file module, which is the Python library used for ROS, that is working with the ROS. We have to use different, uh, functionalities that are working between coordination between the ROS and Python nodes. Then Python is more dynamic language. You have to work, uh, with the permissions we use. You can't, randomly put everything. You have to have, get permissions and import the libraries to work with that library. Every library and every module is for specific functionality. So RAS5 is at that kind of module that are working with the ROS. From geometry message, as we already have created this package, inside of this package we have declared before that it also have the functionality of geometry messages. The geometry messages, we have checked the reverse type from that geometry message. Reverse type have two components. Generally, it have three components. One is the linear dot x, linear y. Um, Basically, it works on vector three of the coordinate system x, y, and z. So we will also explain this. Um, the pro the proceed code we will also explain this. Before we have explained the main, the callback function. This is the functions that we will uh, call oftentimes whenever we have changes to our this node. We will call this function repeatedly to you know send the command uh, repeatedly before we have shut down the ROS5 functionality. We also explained it have the functionality of initiate the node, publish the node, and they have unsubscribed to the node. So ROS5 first initiate the node. We have given the name to this node, that is move forward node, and it is anonymous true. Anonymous true means that this node is unique, and whenever uh, other node present with the raw file that use this node is named move forward. This is unique, and it's not matched with other nodes that are present in these packages. So we have object declare, and after that ROS file publisher we have call it to get from ROS file publisher, and we have the topic. We already in the previous meditation I have told you that we will have different topics that will be coordinated managing by the ROS master ROS core. That is the topic. We will send that velocity command on this topic. The velocity, the command, the messages that we have import are the twist type. The twist type is the coordinate system messages, that is X, Y, and Z. We will also explain. And at the one key size, Python 3, if you have studied that key, that is size of 10. It means at the one time, at once, you can send 10 messages of the key to which type velocity. So we declared one implicitly one variable to set to this function, and we have a list of movements. We declare one movement list, and inside of this list we have tuples, Python tuples. If you are very new to Python and you don't have basic knowledge of Python, then this video is not for you. You have to go back, learn about basic of Python, learn about the tuples, the list, and the quiz. So you will understand. Otherwise, this will be very confusing for you, and you will not understand it properly. So this is the Python. list. Inside of this list, we have declared different tuples. This is another tuple. This is another tuple. Python tuples. And inside of this tuple, we have three components. Basically, vector three of the coordinate system x, y, z. But in these three things, we have declared three components. That is linear x, z, linear dot angular dot z. For rotation we use the angular direction, of the coordinate system. For that we use z. For linear side, with x-axis we use the linear dot x. For angular we use that, and this is the duration. For that duration, that command will be sent for linear velocity and for angular rotation. So actually linear uh, used for the forward move, on x-axis and also on y-axis. So for stop, we have sent linear uh, at zero velocity. Stop versus during the time of duration. And this is the duration of the time that we have used for that velocity to be sent. And again, we have sent linear 0.2 because participants we have sent on the linear x. After that, we have explained one. We have used one for loop. The loop working as we already have tell you that we have explained three components, that is uh, linear dot x, angular dot z, and the duration. So these loops iterate out the linear dot x, angular dot z, and the duration. So for linear underscore x, for angular underscore z, and duration in moment leaves, we have which message dot linear dot x. Linear dot x is the type of message into which messages of the function of the twist. We already have declared this before, this variable implicitly to the twist command, and twist command text linear dot x, and it assigns to that value taken in the moment live. For Angular also we have take the Angular dot z from Angular z underscore z variable that we have iterate our development place and check these values, and that this message we have published using the pub object of the publish of the ROS file. And for the duration, we have ROS functionality, use the ROS sleep functionality, and for that duration, we are stop sending the command to uh, that particular topic that we have explained before. That is command velocity. So, and we have this is the sequence. There are alternate values will be following the sequence, and we have used again the functionality of the ROS file to give the signal to ROS to be shut down. After that, we have checked some conditions, some exceptions that we have. So as this is the main function we are calling, as the function is the main function. It's not imported. It is main function of this Python node, and it is called. We are calling it, and any exceptions that occur during that sequence and the process of the node execution, we will be stopped. Mostly we use control plus C to stop the node. This is one of the Python nodes. I have shown you to have a concept how basically the Python nodes are working. So in the next very sessions, I will show you how this node of Python will send command velocity to the topic of command wall, and that topic we have the run the ROS code, the ROS master on the terminal, and we will have import the port of the microcontroller Arduino. From that hardware, we have the RC rover, and we will control that rover in the next very session. And I will explain and the whole functionality, how the ROS code, and how the Python publisher. This is actually the Python publisher, and Arduino state will act as a Python subscriber, and we will communicate it and control the RC rover. So thank you. By I'm giving thank you, and we have reached to the advanced topics of the ROS. And the next very sessions we will explain more in depth of how the Python knows working and in how we send the command velocity. So thank you. Best of luck for the next very session. And